Welcome back, learners. So as we have said, we are moving on now to the next part of our application questions, or the next set of the questions, which are the application questions. So the first application question says, the general form of the reaction between an acid and a metal is, we know that whenever an acid reacts with a metal, we're always going to produce salt plus the hydrogen gas. And remember that the hydrogen gas is a diatomic molecule, so it's written as NH2. So then, for each of the following reactions we need between the acid and a metal, we need to write down the word equation and then a balanced chemical equation. For when hydrochloric acid reacts with calcium, calcium is our metal, hydrochloric acid is our acid. So we know that the salt and hydrogen atoms are going to be produced. So therefore, the word equation will then be hydrochloric acid plus calcium will react to form the calcium chloride Why? Because the calcium is the metal, then the chloride coming from the hydrochloric acid after the HCl has donated its hydrogen, the non-metal part being the chlorine, will chemically bond with the calcium to form the calcium chloride, and obviously there's going to be hydrogen gas as the byproduct, the hydrogen gas. Then the balanced chemical equation, we know hydrochloric acid chemical formula HCl plus calcium Ca, then the product is going to be calcium chloride, which is going to be CaCl2 plus H2. Then after having done that, we need to make sure that the number of atoms are equal on the left-hand side and also on the right-hand side. So we're seeing that on the right-hand side, we have 2 hydrogens, but we have 1 hydrogen there. So starting by balancing the hydrogen, if you put a 2 there, that 2 is going to affect everything. It's going to now make us to have 2 hydrogen atoms and 2 chlorine atoms. Because now we have 2 hydrogen atoms, that balances that. 2 chlorine atoms, it balances the 2 Cl atoms there. We also have 1 calcium atom and 1 calcium atom. So therefore, this equation is going to be balanced by just inserting the 2 there. Remember that when we are balancing equations, we are using coefficients. We never change the number at the bottom being the subscript. You always change the coefficient, which is the number in front that you have added there. Now, sulfuric acid and lithium as the reaction, we need to write the word equation for that. So we are having sulfuric acid plus lithium reacting to form lithium sulfate. It's lithium sulfate plus obviously the hydrogen gas there that is going to be there as one of the products. So it's going to be hydrogen gas. Then the chemical formula. We know that sulfuric acid has a chemical formula of H2SO4 plus lithium is Li. This is going to react to form lithium sulfate, which is Li2SO4, and obviously that hydrogen gas will be there as our H2. Now, we need to then make sure that the number of atoms on the left-hand side are equal to the number of atoms on the right-hand side. So we have 2 hydrogens, 2 hydrogens. In this case, our hydrogen is balanced. We have 1 sulfur, 4 oxygen, 4 oxygen, but 1 lithium and 2 lithiums. So therefore, that is an easy fix. If you just put a 2 there in front of the lithium, we now have 2 lithium atoms on the left-hand side and 2 lithium atoms on the right-hand side. And with that, the equation is going to be balanced. Next question. Still in keeping with the acid and metal and reacting to form salt and hydrogen, we're now given the reaction between hydrochloric acid and sodium. So the reaction, the word equation for that will be hydrochloric acid reacting with sodium, and the product is going to be sodium chloride, and hydrogen gas, as always, between the reaction of an acid and a metal, hydrogen gas. Then the chemical and balanced chemical equation for this, we know hydrochloric acid, it is HCl, reacting with sodium, it is Na, the product is sodium chloride, so that's going to be the Na, which is the metal part, and the chlorine part after the H has been donated, it's going to be NaCl plus H2. Now notice that on the left hand side we have one hydrogen atom, but on the right hand side there's two hydrogen atoms. So therefore that needs to be balanced. So because we have two and we have one, if I just put a 2 there, that 2 tells me that in that HCl I now have 2 molecules of hydrochloric acid, which means there's going to be 2 hydrogen atoms and 2 chlorine atoms. So the 2 takes care of the hydrogen, but it creates another problem with the Cl, because there's 2 on the left, but there's 1 on the right hand side. So if I then put in another 2 there, let's just create space. If I then put in another 2 there, that 2 tells me that I have 2 molecules of NaCl, which means the chlorine, there's going to be 2 of them. But that creates another problem with the sodium, because now there's going to be 2 sodium atoms on the right hand side, but 1 sodium atom on the left hand side. So if I just quickly put in a 2 there, it takes care of everything, because now there's 2 hydrogen atoms on the left, 2 hydrogen atoms on the right, 2 chlorine left, 2 chlorine right, 2 sodium left, and 2 sodium on the right hand side. So now we can safely say that the equation is balanced. Now the next question says, the next part of the questions are telling us that heartburn is a medical condition when too much acid is produced in the stomach, right? So the question is the stomach acid a strong or a weak acid? Because the stomach acid needs to be able to digest or to break down the food that we eat, it needs to be a very strong acid, right? Because if it's a weak acid, it won't be able to digest and break down the food that we eat, because we eat different kinds of food and a lot of it every day. So therefore, that is going to be a strong acid. It's a strong acid. So we have an extremely strong acid in our stomach. That's why we can have the heartburn, where we feel something burning when on our throat going up. Number 2, we need to give the common name or the scientific name of stomach acid. So we know that the stomach acid is basically known as the gastric acid. However, that gastric acid, it contains, so it's a gastric acid which contains HCl, which is our hydrochloric acid. Hydrochloric acid. So we have hydrochloric acid in our stomach. And we know that hydrochloric acid is an extremely strong acid. It's very corrosive, which is why it is able to break down the food that we eat, anything that we are putting in our mouth and eating and swallowing, that HCl is able to break it down. So because of that, it's a strong acid, it's HCl as we know. Will that now make it to have a what pH? What is the approximate pH of the stomach acid? So if it's a strong acid, it must be further away from 7 going towards 0. We do know that the approximate pH value of the acid, of the stomach acid, it is between 1 and 3. So it is between 1 and 3. So that tells us that it is a very, very, very strong acid, because you know 3 is far away from 7. So therefore that is, and also even 1 for instance, is far away from 7 by looking at a pH scale starting from 0 all the way to 14. And from 0 to 7, we know that 0 and 1, they are far away from 7. So that means the pH of this particular acid, it is very, very strong. So learners, before now we go on to the next part of this lesson, we are just going to quickly go for a short break, and I will see you just after this.